All right, so back where we left off, we found the optimal demand for X and Y at a given level of prices in income level. Now what we want to do is have M is equal to 10, PY is equal to 2, and then we want to vary PX. And we want to solve for the optimal demand of X, or the optimal consumption of X. Now the good thing, the reason why we did it with PX's and PY's up here was so that we already have this. We don't need to solve it again. We just solve it once and then we keep using it throughout the problem. So we solve for, above, we solved for X as a function of M in PX. So we know that this is pretty easy in the sense that we already did it in the previous problem. So we have that X is equal to 2M over 5 px. So when m is equal to 10, this is just 20 over 5 px. So this tells us the amount of x that we buy at any given price of x. Okay, so yeah, nothing more to it. We just literally plugged in these numbers to the equation that we derived in the previous problem. Okay, now for part D, what we want to do is we want to consider the same prices as in B. So Px is equal to 3, Py is equal to 2. And we want to express the demand of goods x and y as a function of m. Then we derive the expression for the Engel curve and determine if good x is inferior or normal, and the same thing for good y. Okay, so again, we solved for the optimal x and y right here. We solved for it in terms of m and py, so all we have to do in this next part of the problem is just plug in some values. So I'll bring that guy down here, and then, so for D, we have this. Now when we're varying m, we're setting px equal to 3, py equal to 2. So x star of m, y star of m. Oh, sorry, I'm gonna move this down. So what I'm doing is I'm just plugging in px and py into this equation, and I'm leaving m as a variable. So we get 2m over 15, and then the consumption of y is going to be 3m over 10. All right. Yep. So this basically tells me, given prices px is equal to 3, py is equal to 2, this is what I will buy at each income level m. Okay. So what I want to do is for the Engel curve for x, I want to look at the income level as a function of x. So this is kind of a backwards way of looking at it, but essentially what I want to do is I have x is equal to 2m of x over 15. This is if I want to go backwards. If I want to solve, if I want to plot x and m of x. So basically what I'm saying is for a given level of consumption of x, this is the level of income I would need to afford that, or for that to be my optimal choice, rather. So we could also, one way we could also do it is to just look at m and then look at x as a function of m. And you have like your Engel curve, and then you just or you have this curve and you invert it to go here. You just flip the graph. So if we have this and we're looking for income m as a function of x, what we do is we just rearrange this. So we get 15x is equal to 2 m of x. And then this means that m of x is 15 over 2 times x. So if we plot this here, we can see that this is a line with a pretty positive slope, and our Engel curve is going to be like this. Similarly for y, we have that y is equal to 3m over 10. So this means that 10y is equal to 3m of x. Sorry, not m of x, m of y. So then m of y is equal to 10 over 3 times y. Right, so it'd be like kind of a slope aligned with this slope. That'd be the Engel curve. Okay. Now we can see that both of these are increasing. So they both have positive slopes, which means that they are both normal goods. Oh, sorry. I shouldn't have looked at this one. I should have looked at if we take the derivative of x with respect to m and take the derivative of y with respect to m, we see that they're both positive. Yeah, so x and y are both normal since their derivatives with respect to m are positive.